class, so today we are working on assignment number 3, which is going to be parallel lines and the midline theorem. I'm just going to start off by quickly reading the question to you. I've chosen question number 2 for us to go through. So in every quadrilateral, there is a hidden parallelogram. You can find it by joining the midpoints of the 4 sides. For example, in the diagram below, if you join the midpoints P, Q, R, S of the sides of the quadrilateral ABCD, then you will obtain a parallelogram. The question is asking, so let's highlight the question. Can you explain why this always happens regardless of which quadrilateral ABCD you start with? So let's go through this. The only way that we're going to be able to explain why this always happens regardless of which quadrilateral ABCD you start with is going to be using what's called the midline theorem. So the midline theorem states that when you cut, let's write this down, when you cut a section along the midline, of a triangle, or a shape, in this case we're using a quadrilateral, that makes a triangle, when cut, it creates a segment that is parallel to the base and half as long. Okay, perfect. Sorry, I know that was a lot of words, but it is really important for us to know. So when you cut a section along the midline of a triangle or a shape that makes a triangle, when cut, it creates a segment that is parallel to the base and half as long. So that last part, parallel to the base and half as long, is what we're going to be looking for in our diagram. So I've drawn a bigger one to the side. Your guys's will be a little bit smaller than mine, but that's okay. Just bear with me and work with what you have. So let's do this. So in this quadrilateral, the midline is going to be drawn from A to C because that is the midpoint in our shape. So we draw the midline from A to C, and let's take a look at what lines we have formed now. So parallel from A to C is going to be P to Q. So these two are going to be parallel. It is parallel to AC and is half its length. This follows what we just said, the midline theorem, which states that parallel to the base and half as long is A to C and P to Q. So let's take a look at, next is going to be S and R, or sorry, R to S and A to C as well. And we can also see that R to S is going to be parallel and half as long as A to C as well. So therefore, sorry, just changing pens. Therefore, we know that PQ is parallel to RS. And we can see that by just taking a look. So P to Q and R to S, they're both equal to A to C, which means they are both parallel and equivalent, which implies that PQRS is indeed a parallelogram. Perfect. So the question's asking, let's remember, can you explain why this happens regardless of which quadrilateral A, B, C, D you start with? So we've now determined that this is definitely a parallelogram using the midline theorem. Let's say that this will always be the same. This will always happen to answer the question because the parallelogram will always have the same side lengths that are parallel to each other. In its own quadrilateral. I'm just going to abbreviate that by saying quad. Perfect. And that is actually it for this question. It is pretty simple. If anybody has any questions they'd like to ask me, feel free to send me an email. And yeah, that's everything for today. Thank you.